Hello and welcome to this video presentation of the weekly project Milestone 4 done by Georgio, Sayah and Anthony Saaeby. As you can see here, we've built 4 different circuits in order to meet the objective of this project. The objective of this project was to find various specifications of 2 different motors, a simple DC motor and a DC motor connected to a rotary encoder. So the first circuit we're going to look at is this one, which is a simple circuit we used in order to note the change of RPM while varying the voltage, while assuming that the RPM shown here is the RPM with no load attached to the motor. And these values were used to find the voltage constant of the motor. And as well, we used the current seen here as the no load current, and it was noted in the graph and written in the report. Now, in order to compare the Arduino duty cycle variation to the ones that we variated here, we used this Arduino board. So we used this Arduino board in order to vary the Arduino duty cycle using this simple code you can see over here. So by varying the analog write value here between 6 different intervals, we also noted the change in the current and the voltage in order to detect the variation of the motor rotation speed with respect to the Arduino duty cycle provided. And this circuit was connected once to this simple DC motor and once here, and we noted the change of RPM. Now for the second part of the project, it was to repeat some of the steps taken for the simple DC motor. So back to this circuit over here, if we start the simulation, we also use this power supply in order to provide voltage for this rotary DC motor with the encoder, and note the RPM values and the no load current over here. And again, to find the relation between the Arduino duty cycle and the DC motor rotation speed, we used this circuit over here with the provided code earlier and varying the Arduino duty cycle in order to know the change in RPM with relation to the Arduino duty cycle. Now, for the question where we had to find the number of pulses of the DC motor with the encoder, we used this circuit over here, which had a different code. We can look at the code over here. Okay, so this code was written and used in order to detect the frequency of the motor at first, and then do some calculations in order to turn this frequency into the number of pulses, to the number of pulses per revolution. So to explain the code a bit, we first initiated several integers or variables, last read and interval 1000, which was used to create a 1 second comparing value, a count equal to 0 and a new count also equal to 0 with and a pulse number variable. So this void frequency counter, which will be initiated at every interrupt, it will add a count 1 every time this void loop is entered. And now for the void setup, we initiated the serial monitor, which we'll be seeing soon when I start the simulation. We wrote the value that we detected. First, we wrote the value that at full voltage at 12 volts, here it's 255 because it's a PWM, at 12 volts to the motor, and then we initiated pin 2 as an input and pull up. So as the guides given by the email, we had to put a pull up resistor in order to have good readings of the from the encoder channel that was connected to the second to the pin number 2 of the Arduino, which is the only pin that has which is the only pin that has an hardware interrupt to it. So an attached interrupt was initiated. Digital pin to interrupt is pin 2 as mentioned, and frequency counter will be entered over here and will be adding 1 to the count integer. And rising here is to only detect the rising edges. Now here we're comparing the time since the Arduino has been running minus 0 for the first time we run the code, and to check if it's greater or less than 1 second. Now we disable the interrupt and we create a new variable, which is a new count, and set count back to 0. And we enable the interrupts back. Now this value, the new count, will be our frequency since it's per second, which will only happen when it's greater than 1 second, which is 1000 millis that we initiated earlier. Now we created a delay of 10, and the pulse number is the frequency multiplied by 60 and then divided by which was divided by 2319, which is the RPM at the highest voltage that is provided to the motor. So now that we have the pulse number, we printed it on the serial monitor, and now I'm gonna run the simulation in order to see the simulation take place. So if you open the serial monitor over here, at first, because the simulation time of the Arduino is slow, so for a second to pass it takes a bit of time. So as we saw earlier, the pulse was 0, and then as the speed increases, the pulse reached 24, and finally when the ultimate speed is reached, a pulse of 47 or even 48 will appear now, which is the highest pulse reached. Is the pulse number per revolution of this motor. Uh, so the provided report has all the details and calculations of the project that we did, and thank you for your time.